In this recording, we are going to work out this problem. We have a battery with the voltage or electrical potential across it being given as E, and then we have three capacitors. Capacitor C1 with a charge Q1 and a voltage across it V1, capacitor C2 with a charge Q2 and a voltage across it being V2, and a capacitor C3 with a charge Q3 and the voltage across it V3. First question is asking us to compare Q2 and Q3. Now, what we need to pay attention, how are they connected, C2 and C3? Notice that they are in series. One end of C2 is connected to one end of C3. There is nothing else connected to this end. There is a straight line between both capacitors. So the capacitors are in series. Since they are in series, we know that no charge can enter or exit the segment that I designated here on red, which tells us that the charge Q2 here should be equal in magnitude to the charge Q3. The two charges have to be equal. Okay, so Q2 is equal to Q3. Okay, the next question is asking us to compare Q1 to Q2. Now, in this case, the story is a little different. What do we know about Q2? Q2 is the same as Q3. It is the charge of this equivalent capacitance. If we replace these two capacitors by one capacitor, now the charge of that equivalent capacitance is going to be Q2 or Q3. Now, what voltage is that capacitor subject to? That voltage is in parallel to the capacitor C1. Both of them are subject to the same voltage because both of them, okay, let me use another color, both their ends are touching. So these two capacitors are in parallel. Okay, now remember what we know about voltage, charge, and capacitance. We know that Q is equal to CV. Since these are subject to the same voltage, then we can write Q1 over C1, or Q1 over C1 is equal to Q2 over C equivalent. Okay, this is all what we can do so far. Now, how does the voltage V1 compare to the voltage E? These ends are at the same voltage. So that means V1 and E are equal to each other. What about V2 and V3? We don't know. All what we know is that V2 is equal to Q2 over C2 and V3 is equal to Q3 over C3. Now we know that Q2 is equal to Q3, but we don't know anything about the capacitance. Now, if the capacitors are equal, then V2 and V3 are equal. But if they are different, we are going to have different voltages. What about C equivalent and C1? Okay, the equivalent capacitance is going to be at the end the capacitance of C1 plus the equivalent capacitance of C2 and C3. The equivalent capacitance of C2 and C3 is smaller than either of them, but the equivalent capacitance of C1 and this equivalent capacitor is going to be larger than C1 since it is in parallel to C1, and we add up capacitors when they are in parallel. So this is larger. Okay. So that's all what we can say about this problem. Okay, actually I skipped one, it seems. V1, of course, is larger than V2 because V1 is equal to V2 plus V3. V1 is equal to V2 plus V3. V1 is from here to here, V2 is from here to here, V3 is from here to here. So V2 plus V3 is equal to V1.